Hello guys, today I am going to tell you how to calculate the t-test in statistics. And in the previous my videos, I have gone through the how to calculate the z-test and as well as a one proportion z-test. And today I am going to take the how to calculate the t-test and with an example. And when we have to take the when we have to consider this t-test during the statistics and as well as when we are doing some in the data science project, means in the machine learning project. Let's go back to the my screen. There I will explain. Thank you. Welcome back. And now I'm explaining the t-test in statistics. First, we will consider when we have to use the t-test. Okay, as I already told you, when you are performing the hypothesis testing, the very important thing is we need to conduct the experiments. And we know that we can't able to conduct the same experiment in all the cases. And there are different scenarios will be there. There we have to carry out the some different test like a z test, t test, chi-square test. These are the different examples. We can't consider the test for all the cases. Now, as I already told you in my previous video, okay, when we have to use the z test, when they are going to give the population mean and as well as the n value is greater than 30, in that case we are going to go for the z square test. But here, when the problem contains the population size is less than 30, then in that case we are going to use the t-test. In Python, when we have to use the t-test, actually in Python, when you are solving some machine learning related problems, when there is a one continuous variable, you have to consider, okay, for the feature selection. In that case, we are going to go for the t-test. See, these are the two hints for using the t-test. The first one is the n value is less than 30. Just I will write it out here. N value is less than 30, then you have to use it. Okay. Then what is the formula? The formula is very simple here. Okay. I think it should be T. Okay. The final formula for this t-test is x bar minus mu naught divided by standard deviation divided by square root of n. X bar is sample mean and the mu naught will be the population mean divided by the standard deviation of that sample, square root of that sample. Okay, n is the value of the population. And see, let us take one example. See, I have pasted the t table here. Okay, before going to the, I will tell you how to see the values in t table. Then I will show you how to calculate the value from this using this formula. See, you are going to get two values. One value is through the calculation and another value is through the tabulated. Means you need to compare the calculated value with the table value before going for the decision. Okay, see, that is the procedure for performing the test over here. Okay, let us take one simple example. There are 6 different weights are there. Okay, I will come for that. Yeah, see, these are the 6 different weights. Okay, assume that the data will be like this: 2, 1, 1.4, minus 1.8, 0.9, 2.3. See, we are going to conduct the t-test because the number of samples they had given is here is 6. And assume that it is a one-tail test. Assume that it is a one-tail test. And here the summary of the statistics means after performing the x bar, the mu and as well as the standard deviation, you are going to get 0.966 as the uh, mean of this particular table, and standard deviation is 1.462. Okay, then I will go for the next one. Here first we need to calculate the t using that formula what I had explained. Here x bar they are already given, the population mean they are not given, hence I have taken as a 0, then 0.966 as I shown in the previous slide, and divided by s is the standard deviation and divided by n is the sample, how much sample is there, that is square root of 6, and the value you are going to get will be 1.619. See, this is the calculated t value. This is the calculated t value, and the critical region they already given, it is alpha equal to 0.05. Okay, then we have to check. Okay, we have to reject if the calculated t value is greater than t of 0.05. Means we need to check for this critical region for one tail test what will be the tabulated value. Okay, let us check what is this degree of freedom. Okay, in the let us go back to this. You can able to see the df here. Okay, see, this is the we need to identify how to get the degree of freedom is it is n minus 1. Remember this. Degree of freedom equal to n minus 1, where n is the sample number of samples. Here in our case n value is 6. Sorry, I will increase the font size. So the same example I copied here to explain. Okay, see the n value is the same number of sample. We have how many number of, what is the n value of, what is the n value in the previous example? N value is 6, then the degree of freedom, the df equal to 5. Okay, see this is the thing. Here we got the degree of freedom now. See the degree of freedom is this. Then the alpha value they already given. Alpha value is how much? 0.05. Okay, we have to check whether it is a one tile or two tile. As I already told you, it is a one tile test. Then I need to go for this particular, this value 0.05. What is the value? I am going to get 2.015. See, that is the value. 2.015 is the tabulated value for that problem. Remember, to see this, to get the tabulated t value, first we require is the degree of freedom. How to get the degree of freedom is n minus 1. If they are not going to give the sample, we have to use the separate formula. If they are going to give a table type of structure, in that case we have to use number of column minus number of column minus 1 into row minus 1. Okay, that value will give you the degree of freedom. But in this case, it is very simple, n minus 1. Since n is 6, 6 minus 1 is 5. Means we are going to get the degree of freedom as 5. Then we have to consider the alpha value. The alpha value is given here. And very, very important thing is you have to check for whether it is a one tile or two tile. If you make a mistake here, then again you are going to get a different value, then your decision will be different. Since I already told in this example, it is a one tile test, then I am going to consider this topmost row. Okay, then with respect to the degree of freedom, then it is 2.015. Okay, let us go back to our example. See, as I told you, it is 2.015 for a 5 degree of freedom. Since the calculated t value is 1.69 is greater than t of 0.05, means the calculated t value is greater than the tabulated value, then we have to reject. Okay, we have to reject the null hypothesis. But in this case, since 1.69 lies, it is less than 2.015, then we have to accept the null hypothesis. See, this is how we are going to perform the t-test for a t-test in statistics. Thank you students. If you have any doubts or any comments you want to give, please write it in the comment box, and if you like this video, you share it among your friends. Thank you for watching my video. Please give suggestion, and if you like this video, please give a like button and subscribe to my channel. I'll keep on posting the videos related to the statistics and as well as the data science projects related queries, and how to carry out the machine learning and the deep learning projects. In future, I'm going to upload a separate playlist for each and every courses with respect to this. And if you like this video, please share it among your friends. Thank you.